All right, geometry students, welcome to 12.4, 12.5. 12.1, you may recall, was representations of three-dimensional figures. We were working with visualizing three-dimensional figures, trying to picture them in our mind's eye, different views of them. 12.2, 12.3 went together. They were both surface area and lateral area of our four main three-dimensional figures: prisms, cylinders, pyramids, and cones. And now 12.4, 12.5, we're actually going to combine together. It's going to be very straightforward. Volumes of our four main three-dimensional figures. You're going to get a couple formulas. It's going to be very easy to memorize, even though I wouldn't expect you to memorize them anyways. All right, so let's get going with a definition on volume then. When you think volume, what's the definition you think of? Probably, well, maybe not probably, but at least hopefully, you're thinking of along the lines of the amount of space that an object takes up, or how much space is inside an object. If we take a look at this maybe helps us remember that there's going to be three dimensions to the measure of volume: a length, a width, and a height. And when we've got something simple like this, we can just take length times width times height to get our volume. Basically, we're thinking how many of these cubes fit in this shape. All we would have to do for that is take 6 times 4 to get the bottom layer. It's 24. And there's 2 of those layers, so take it times the 2, and that gives us 48. So basically what we just did, we took 6 times 4 to get the base. We take the area of the base times the height, and that's our simple formula for volume of a prism. Base times height. Area of the base times the height. Find the volume of the prism. The one tricky thing that you maybe keep running into with these guys is this is a triangular prism. The base of this thing is the triangle. Don't try to find the area of this rectangle and then take it times 10. That would be inaccurate. You want the area of the triangle and take that times the height 11. Picture this thing standing on its triangle. So if volume equals base times height, area of our triangle is going to be 1/2 base times height. 1/2 12 times 10. It's going to end up being 60. And our height, if we stand it up, is going to be 11. 60 times 11, 660 centimeters. Volume is a three-dimensional measure, so we're going to say centimeters cubed. And just like that, we are on our way to the next problem. Find the volume of this prism. Not quite as easy because our base ends up being a little bit trickier to find the area of. Volume equals base times height. We need to find the area of this base. We've got our pentagon going on here. In order to find the area of a pentagon, we need to take 1/2 perimeter times apothem. Check it out. They already gave the apothem to us. That's glorious. All we have to do is plug it in. 1/2 perimeter times apothem. 1/2 times the perimeter is 5 times 5, or 25. The apothem, here it is, given to us, 3.4. On la calculadora. 12.5 times 3.4 gives us 42.5. We're plugging that in for our base. I'm going to take that times the height, which is 8. 8 times 42.5 is 340 millimeters cubed. All right, very straightforward when we're talking about volume of a prism. And it's as straightforward when we're talking about cylinders. Still base times height. It's the same as a prism, except we usually write the area as pi r squared. So we'll call it pi r squared h. All right, this guy. If pi r squared h is our formula, we have to see what we know. Pi is just a number. Plug in r. Now, this pink line is depicting that 9 inches goes with the whole diameter. So our radius is half of that, 4.5. And we take that times the height, which is 5. Very, 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 very easy. As long as you know how to use a calculator. 318.1. We could round to anything since it doesn't tell us. Inches cubed. All right, how about you try the volume of a cylinder on your own, except we have to talk about Cavalieri's principle first. Tell me about these books. If we have these 3 books, and we talk about their volume, how much space they take up, and then we lean those books over, do they still have the same volume? I think it's pretty obvious that the amount of material that makes up those books has not changed. And that's where Cavalieri's principle comes from. It doesn't matter if we have a right solid or an oblique solid, as long as our cross-section area is the same throughout the figure, and the height is the same, they're going to have the same volume. So now we can do right or oblique. You're going to try this one on your own. Alright, so right cylinder, oblique cylinder, doesn't matter. We can still use pi r squared h, plugging in the information that we have. 1,357.2 meters cubed. Moving on to pyramids then. Alright, so prisms and cylinders, same formula, base times height. Pyramids and cones are also going to be the same thing. So if we picture a pyramid as being the same thing as a prism, square base going up, except we're taking some of those corner pieces off. Those corner pieces that we take off end up meaning that we're only taking up 1/3 the amount of space as we did before. So instead of volume equaling base times height, now it's going to be 1/3 the area of the base times the height. So pyramid is 1/3 base times height. Here's a nice rectangular pyramid for us to deal with. We'll take 1/3. By the way, I really am hoping that this yellow being slightly different than the other yellow of these words is bothering you. That's kind of why I chose it. Alright, so we're going to take 1/3 area of the base. 8 times 9.5 should be 76. If I did that wrong, go ahead and give me on a mistake. And our height is 9. Take 1/3 times 76 times 9 should be 228. Did that all in my head, so great chance of having a mistake. And of course that's going to be in centimeters cubed. Pretty easy stuff. You're going to do the same thing with this one, a triangular pyramid. 1/3 base times height. Area of a triangle is 1/2 base times height. 1/2 times 6 times 15 is 45. Our height is 14. 1/3 times 45 times 14 gives us 210 feet cubed. Boom, done with prisms, done with cylinders, done with pyramids. Now we're going to cones. Like I said, cones is going to be very similar, in fact the same as pyramids, because we're still taking up 1/3 the total volume. So we're going to be 1/3 base times height, or 1/3 pi r squared h. Alright, so here's our cone. This one's going to try to make us work a little harder. We need 1/3 pi r squared h. One-third is just a number. Pi is just a number. Now you're looking for a way to find the radius. The way it's going to make us work a little harder is because we have a right triangle here. They're giving us a degree measure formed by the radius and the slant height there. Basically, we're just going to use a trig equation to solve for the slant height. Oh, not going to solve for the slant height. We don't need the slant height. We're going to solve for the radius. So I'm going to use what? Opposite and adjacent, which means I'm using, that's right, tangent. Tangent of 58 equals opposite over adjacent, in this case 11 over r. Variables in the denominator, so we will divide. 11 divided by tangent of 58 gives us a radius of 6.9. Slap that into our volume formula. Our height we know is 11. And we'll pull that into our calculator. 1/3 times pi times 6.9 squared times 11. And we should get a final answer of 548.4 inches cubed. All right, last one. Find the area of this cone by your lonesome. And a little plug and chug should come up with 66.0 feet cubed. Basically, two formulas from this lesson, actually this combo lesson. Base times height and 1/3 base times height. Here's your assignment. Do this all on one sheet of paper, or two if it takes you there, but don't do separate sheets on purpose.